Hello, friends. Thank you once again for joining me. In this session, I want us to look at a question in linear motion, uh, and a subtopic we call relative motion. So here is a question we have, as it reads, that we have a bus left town A at 8 a.m. and traveled towards town B at an average speed of 80 kilometers per hour. At 8:30 a.m., a car left town B for town A at an average speed of 120 kilometers per hour. Given that the distance between the two towns is 400 kilometers, calculate part A, the time the two vehicles met, and then part B, the distance from town B when the two vehicles met. Now, when you're given this, to begin with, it's advisable you just draw a bit of a sketch just to show the location and the distance between the two places. Now we have town A and town B. So the bus leaves town A at 8 a.m. at a speed of 80 kilometers per hour. Okay. And the car leaves town B at 120 kilometers per hour, but 30 minutes later at 8:30 a.m. So first of all, we can see that the bus leaves or starts traveling earlier, 30 minutes before the car. So what we need to do is to find the distance covered by the bus by 8:30. Okay, that is 30 minutes before the car starts traveling. So in that case, we say that the distance, we know distance is speed times time. So speed times time. So the speed is 80 kilometers per hour, and the time is 30 minutes, which is 30 over 60. We have to convert it into hours because we are multiplying by 80 kilometers per hour. So that is half an hour, and that gives you 40 kilometers. So you can come and indicate here that 40 kilometers shall have been covered by the bus at 8:30 a.m. So remember, the bus is going in this direction, the car is coming in this direction. So the total distance between the two towns was 400. So by 8:30, 40 has been covered. So we remain with 360. So by 8:30, the common distance to both vehicles when they are both moving is 360, being the difference between 400 and the 40 that had been covered earlier. Now here, the question is asking us to find the time when the two vehicles met. So before we do that, before we get that time, we need to get the time taken before they met. Now to do that, now we have the distance to being covered by both vehicles when they are both in motion is 360. So at this stage, we use what we call relative speed. So we find what is called relative speed. So the relative speed, when vehicles are approaching each other, the relative speed is determined by or is found by addition. So this will be 80 plus 120. 80 being the speed of the bus and 120 being the speed of the car, which is 200 kilometers per hour. So therefore, time taken to meet get to know that time taken to meet is different from the time of meeting. Okay, so time taken to meet is the duration. The time of meeting is a particular instance. So in this case, the time taken to meet, of course, I know time is distance over speed. Now we take the common distance when they are both traveling, 360 over 200. And that gives you, when you divide this, you'll get 1.8 hours. Okay. 1.8 hours, which is essentially 1 hour and 48 minutes. 0.8 of an hour is 48 minutes. You take 0.8 and multiply by 60 to convert into minutes is 48 minutes. So this is the time taken for the two vehicles to meet. So the time of meeting, as asked here, the time the two vehicles met. So the meeting time, therefore, meeting time, you add to the time that they were both in motion, when they were both in motion, at the point when they were both in motion, which is at 8:30. So we have 8:30 plus the time taken to meet, which you've calculated there, which is 1 hour and 48 minutes. When you add this, here you'll get 78. 78 is actually 18 minutes past the hour. So we have 18 and then carry 1. So 8 plus 1 is 9. Then plus 10 plus 1 is 10. So the meeting time was 10:18 a.m. Good. Then in the second part, we ask the distance from town B when the two vehicles met. Okay, distance from town B. So if this is town B, so we're being asked. Now they met in between here. So we need to know in between here. So we need to know how far, the question is asking us how far it was the meeting point from town B. So we can take, because they met after 1 hour and 48 minutes, that is 1.8 hours. So we can take the speed. You can use the speed of the car which is coming from point A. So in this case, therefore, the distance from town B will be, of course, distance is speed times time. Now we take the speed of the car, which is coming from town B, which is 120, then times the time, which is 1.8. And if you work out that with your calculator, you should be able to get it is 96. I'm working it out manually aside here. So that is 6, that is 11, that is 2, 0, and this translates to 260. 19 kilometers. This is the answer to this second part. So thank you so much for your audience. If you have any question, feel free to ask in the comment section. And if you haven't subscribed, please, I request you to subscribe and even share this with your friends. And remember to press that bell button so that when I post a new video, you'll be notified. Thank you so much for your audience. Bye bye, and always take care.